Good morning, students. Jai Swaminarayan. In the last lecture, I think we have done up to sum number 2 of exercise 7.4. Now, students, we are starting from third sum. Now, basic revision of formulas we will do. And then, students, we will start from sum number 3. Now, students, recall the definition of combination. The total random selections of R things out of given n things. The total random selections of R things out of given n things is called combination of R things, denoted by NCR, and the formula of NCR is n factorial upon R factorial into n minus R factorial. The total random selections of R students out of given n things is called combination of R things, denoted by students NCR, and the formula of NCR is n factorial upon R factorial into n minus R factorial. Then this we have already studied. NER is equal to R factorial into NCR. If I multiply NCR by R factorial, then students, I get NPR. The third important formula was NC0 is 1 and NCN is also 1. From given n things, I select all n things. That can be also done in one way. And given n things, I reject all. That can be also done, students, in a way. Then, students, fourth, NC1 is equal to n. Given 4 pairs of shoes, I can select any one in 4C1 4 pairs. Given 10 different pens, I can select any one in 10C1 is equal to 10 pairs. In general, given n things out of which I can select one in NC1 is equal to n ways. NC1 is equal to n ways. Then, students, the important properties, NCX is equal to NCY. It implies x is equal to y or n is equal to x plus 1. Last but not least, NCR plus NCR minus 1 is equal to n plus 1 CR. These are the fundamental basic properties which we have revised. So, students, this is what was the total concept of students NCR combination. Okay, students, now all of you please pay attention and concentrate. Now, students, how to apply the formula of combination. Our next target, our next concept is to apply the formula of combination. Say I am given 5 pairs of shoes and I am selecting any 2 pairs of shoes. Then, students, that can be done in 5 simple ways. I am given, say, 5 different items and I am selecting maybe 2, it can be done in 5 2 ways. Given are 10 different options for, you can say, a furniture, and we have to select any 3, then the 3 items can be selected in 10 C3 ways. Given are x items, after which I am selecting any y, where y is less than or equal to x, it is x C y. So given are n items and you have to select any r items, so it can be done in NCR ways. This you should never forget, students. This is the main concept of combination. And the master key of P and C is this words. Students, I say master key in combination and permutation is this words. For arrangement we use permutation, and for selection we use combination. So this is the master key of entire chapter. Students, why I am telling master key? Because in examination you will never be told that this is the sum of permutation and this is the sum of combination. You have to yourself read the sum, understand, and students, correspondingly you have to, you can say, apply the concepts. So one has to be very, very careful and cautious, students, about the concepts of, you can say, permutation and combination and its application. Students, application of the concepts is very, very important. So if you have selection or draw, draw is also selection, and if you have arrangement, ordered arrangements, then students, you have to use permutation, and if it is selection, then students, we have to use combination. This is what I want to emphasize upon. Now students, we start with sum number 3. How many chords can be drawn through 21 points on a circle? Say this is a circle, and on this circle we have 21 points. Say this is P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, P12, P13, P14, P15, P16, P17, P18, P19, P20, and say this is P21. Suppose this are the distinct 21 points on a circle. I have shown all the 21 points for your understanding. Using this 21 points, how many chords can be formed? Now students, you must be knowing what is a chord. A chord is a directed line segment. Say, I join P21 and P2. This is the chord. I join P2 and P6. This is a chord. I join P15 and P9. This is a chord. A chord is a line segment joining 2 points on a circle. A chord is a line segment joining 2 points on a circle, and the longest chord is the diameter. Now total we are given 21 points. This is given. Now for a chord we need 2 points. So directly given is n is equal to 21. We have to select r is equal to 2. So from 21 points, any 2 points can be selected in 21 C2, and those selections are equivalent to the number of chords formed. So how many chords using given 21 points can be formed? Then the answer is to this 21 C2. So if I simplify, this will be 21 factorial. 21 factorial upon 2 factorial into 21 minus 2. So 21 into 20 into 19 factorial upon 2 into 19 factorial. 2 1s are 2 10s are. So the number of chords formed using given 21 distinct points on the circle are 210 students. This is how we have to apply the fact set. So given r n is equal to 21 points for a chord which is a line segment joining 2 points on a circle, we need 82 points. So number of chords formed is equal to 21 C2, because given 21 distinct points, we are selecting r is equal to 2. In how many ways 3 girls and 3 boys can be selected from 5 boys and 4 girls? Okay students, answer 4. Given are 5 boys and 4 girls. Now another important concept of permutation and combination is AND OR theorem. Students, AND indicates multiplication, OR indicates addition. This, students, again is a master key in permutation and combination. This is the second master key of permutation and combination. Students, this is the second master key of permutation and combination. For AND we have to multiply, for OR we have to add. Now out of 5 words, I am showing like this. Out of 5 boys we have to select 3 boys, and out of 4 girls we have to select 3 girls. So total selections, the word selection indicates combination of 3 boys and 3 girls, and means multiplication. Now from 5 only 3 boys can be selected in 5 C3 and single. From 4 girls only 3 can be selected in 4 C3 ways. So this will be 5 factorial upon 3 factorial into 2, and this is 4. Why? There is a shortcut for this. If your R is less than n by 1, the answer is n. 5C4 will be 5. 10C9 will be 10. 25C24 will be 25. So if your R is less than n by 1, answer 11. This is 10 into 4, so the answer is 45 into 4. 3 gets 20 by 2. So how many ways 3 boys and 3 girls can be selected from given 5 boys and 4 girls? The answer is 40. So what is important in permutation? Order. What is not important in combination? The word order. And AND/OR theorem, the word selection indicates combination and the word arrangement indicates permutation. This much, students, if you remember, I assure you, students, you never face problem in any sums. Now, students, we are doing sum number 5 and 6. 2 sums at a time. Students will do. 4th already we have done. So now, students, we are doing sum number 5. The number of ways of selecting 9 balls from 6 red, 5 white and 5 blue. Okay, students, answer 5. 6 red, 5 white and 5 blue. This is, students, given to us. 6 red, 5 white and 5 blue. From this, students, we have to select 3 balls of each color. In total, students, we have to select 9 balls. So, from red 3, from white 3 and from blue, students, 3. We have to select 3 balls from, you can say, each given 6 bunch of red, a bunch of 5 white and a bunch of 5 blue. So, from 6 red, 3 can be selected in how many ways? And the answer is 6, 3. Then from 5 white, 3 can be selected in how many ways? 5, 6, 3. Then same from 5 blue, 3 can be selected in how many ways? The answer is 5, 6, 3. So, total selections of 9 balls wherein 3 balls of each color are 6, 3 and because 3 red and 3 white and 3 blue. So 5, 3, 2, 5, 6, 3. This is our answer. Now, students, only numerical work is left. Apply the formula of NCR. Now, students, only numerical work is left, and that is to apply the formula of NCR. So here, 6 factorial upon 3 factorial into 3 here, 5 factorial upon 3 factorial into 2 factorial, same with 5 factorial upon 3 factorial into 2. Reduce 6 up to 3. 1 3 factorial I write as 6 and 1 and simplify, so this is 20. Reduce 5 up to 3 factorial and 2 factorial is 2. So 10, and similarly this is also 10. So total selections of 9 balls wherein 3 balls of each of selecting 9 balls, wherein 3 balls of each color are there, is 6C3 into 5C3 into 5C3. So the answer is 2000. So students, we have 2000 total selections, and that is quite a large number. Our total selections are, students, 2000. Now students, as far as playing cards are concerned, students, the concept of permutation and combination is incomplete without the sums of playing cards. So today my prime concern is to explain you all the fundamentals of 52 cards. Students, remember this will be very useful in probability also. So I know, students, you all are well versed in playing cards better than me, but as per my duty, I am explaining you, students, the fundamentals of cards. A bunch of 52 playing cards is divided into 4 suits. How many suits, students? 4. Means type suit. S-U-I-T, suit. The 13 cards are of spade. Other 13 cards are of club. Another 13 cards are of hearts. And another 13 cards are of diamond. I am not speaking Gujarati words, you will be well know. I never speak Gujarati in my lecture. So spade and club are black color cards. So if I add, then 26 are black color cards, and hearts and diamonds, total 26, are red color cards. This, students, we have to perfectly understand. So, in a pack of 52 playing cards, we have 4 different suits. 13 cards of spade, 13 cards of club, 13 cards of hearts, and 13 cards of diamond. Now, students, spade and club, 26 cards are black color cards, and addition of 13 of hearts and 13 of diamond, 26 are red color cards. Then face cards, cards having face, are jack, queen and king. So 12 cards are face cards. A jack, a queen and a king are face cards. Mind you, ace does not have a face. Ace does not have a face. Students, ace does not have a face. So, this is the basic of playing cards. 40 cards are non-face cards. We have 26 black color cards. We have 26 red color cards. We have total 4 jacks of each suits, 4 queens, 4 kings, and of course 4 aces. And aces doesn't have face. Aces are without faces. Ace does not have a face. So this will be very useful to you in probability chapter 16, which I am going to take after I complete chapter 8. Our next target is to do chapter 8. After chapter 8, I am going to take chapter 16, students, which is probability. And for that, the basics of permutation and combination is required. For playing cards, this much is base to do certain fundamental sums of probability also, and certain fundamental sums of PHC, permutation and combination also. Now, sixth sum reads as: determine the number of 5 card combinations out of a deck of 52 cards. It is exactly 1 ace in each combination. So, answer 6 now I am continuing. This was altogether the basics for answer 6. So, let us continue. Now, 52 cards I divided like this: 4 aces and 48 others, and we have to select 5 card selection. We have to select 5 cards. Now, as there were conditional permutation, in the same way, students, we have conditional combinations. In the same way, students, we have conditional combinations. Now we have to select 1 ace, and for remaining 4 we are not given any condition. So first I will select ace. Total selections of 5 cards, including 1 ace, is equal to, out of 4 ace, 1 ace must be there. Now which ace will be there, you can never tell. So the selection of 1 ace out of 4 can be done, students, in how many ways? The answer is 4C1. The selection of 1 ace out of 4 can be done in 4C1 ways. Now remaining 4 can be any card from this 48. So other 4 can be selected in 48C4. Now NC1 is N. So 4C1 according to this formula before, 5C1 is 5, 10C1 is 10, 8C1 is 8. So this is 4. And simplifying, this comes out to be 48 factorial upon 4 factorial into 44 factorial. So if I simplify, reduce 48 up to 44 and get it cancelled, this is 7,78,320 ways. 7,78,320 ways in which we can select 5 cards out of a given deck of 52, which includes 1 ace. So students, playing cards are a very important aspect of permutation and combination. Do not play cards at home. Mind, as sir has told. Please students, do not play cards at home. Mind that sir has told. But this was required for our studies. That is why, students, I have emphasized on this details of playing cards. You need not be gambler Baba in order to understand this. So students, here we conclude the lecture. The remaining questions we will complete in the next lecture to complete the chapter. Miscellaneous exercise 7 has been removed from our syllabus. So we don't have to do miscellaneous exercise 7. But do remember today's 2 master key which we are revising again. You will not be told in examination that this is the sum of permutation or combination. You yourself has to identify that this is the sum of permutation or combination. How to identify the sums of permutation? Then it is arrangement. Whenever arrangements are asked, whenever ordered arrangements are asked, that indicates the use of permutation. Whenever selection or draw, either of these 2 words are there, I repeat, whenever we have selections or draw, either of these 2 words indicates combination. Then we have studied AND or here. For AND we have to multiply, for OR we have to add. So another important concept of permutation combination. In terms of master keys AND or theorem, AND or theorem is not specified exactly in our syllabus, but you have to remember that for AND we multiply, for OR we add. So AND or theorem, arrangement in selection, the word order is not important in combination, but the word order is very, very important for permutation. So here we conclude, students, the lecture. Remaining concepts we will take, students, means remaining sums. As such concepts are over, but once again I will revise entire concept of PNC and do the remaining sums of exercise 7.4 in the next lecture. Thank you, students. Have a nice day.